The sloop of war has a proud history in the Royal Navy, from the timber-built battleships of the Napoleonic era through to the World War II Black Swan class, which were used to such devastating effect by Captain Johnny Walker in hunting and destroying German U-boats. The concept of a small, fast, versatile and manoeuvrable warship is finding renewed relevance in today's modern naval scenario. Navies across the world are looking to develop warships capable of being reconfigured for multi-mission capability at an affordable cost. Having produced a front-end engineering design, Cygnus Defence Solutions now aim to provide the detailed design for such a vessel. The Joint Concept Note, published by the MOD, characterises the operational requirements of the Royal Navy, the political backdrop, and sets out the principles which guide the concept behind the proposed new Black Swan class. The increasingly complex and globalised nature of the threats which face a modern maritime nation require a balanced fleet of surface vessels to be able to undertake a wide range of tasks. Thomas Boll is our project manager and is the driving force behind this project. Andrew Avent is our company secretary and document controller. He's an experienced mechanical engineer and has a maritime background. Robert Redman is our lead systems and mechanical engineer. Cyguns Sharma is in charge of graphics, media, CAD administration, and as a mechanical engineer has specified the propulsion systems for the project. Alexander Norman is our naval architect and has produced the design for the main hull and superstructure. Ian Hudman is a naval architect and is our lead draftsman. Cygnus Defence Solutions is an upcoming, innovative and highly skilled design team with the capability to tackle complex design and system challenges. Cygnus has strong expertise in concept design and technology management within the global defence market. The final ship design parameters are a length of 102.5 metres, maximum beam of 15.5 metres, displacement of 2,800 tonnes, and a cruising speed of 18 knots. Some of the key design features are a twin propeller diesel-electric propulsion system, a wide-open helicopter deck for operations up to the size of a Merlin or Chinook, hull and superstructure with the sides angled to 8 degrees to minimise radar signature, bulbous bow designed to reduce resistance and improve seakeeping performance, high-level watertight subdivisions to increase damage stability and survivability. At the heart of the Black Swan is its propulsion and auxiliary machinery. The philosophy behind the design of the propulsion systems can be characterised by two main design drivers: versatility and innovation. The prime mover consists of 4 diesel-electric 2.8 megawatt MAN engines. Opting for a diesel-electric propulsion system allows greater freedom of arrangement not offered in traditional mechanical drive systems. Indeed, by placing systems further apart in different compartments, it gives greater reliability and redundancy. This also leads to increases in versatility by having 4 separate engines that will allow the ship to sail, with each engine operating at optimal performance. MAN will also be supplying the auxiliary engines. This keeps supplier costs down and, more importantly, maintenance complexity to a minimum. Though not mandatory, CDS is pushing the boundaries by actively opting to implement emission control systems without compromising the capability by fully conforming to the EU Tier 3 emissions regulations. One of the key design features of the Black Swan is its capability to store and utilise a range of mission modules to allow the vessel to launch and recover a range of manned and unmanned platforms. This will be essential so that the vessel can adapt to the evolving range of missions over the next 30 to 50 years, and it has been seen as an opportunity to introduce innovation into the design. The vessel will also need to be able to launch and recover not only current platforms, but the platforms of the future. This includes RIBs, AUVs, and USVs. The Black Swan has been designed with both a side deployment system at the front of the hangar and a stern deployment system at the rear of the mission bay. The primary launching method will be the stern deployment system, as it allows access to the mission bay and mission modules, and so will have the capability to deploy a range of vessels dependent upon the mission's needs. The vessel is loaded into a cradle, which is lowered into the water by two winches, in unison, compensating for ship motion relative to the craft. Once lowered into the water, the platform can be remotely released from the cradle. The side deployment facility is the secondary launch and recovery system. Each side will have a semi-submersible cradle allowing the deployment of both surface and subsurface vessels. This cradle is extended out of the side of the vessel by two telescopic crane arms before being loaded into the water. With regards to mission modules and container handling, mission modules will come in the form of 20-foot ISO containers when in port. Side doors will allow the containers to be driven straight onto the mission bay. If this is not possible, a boom crane has been integrated into the deck to allow containers to be lifted onto the vessel. They can then be lowered into the mission bay through a hatch in the deck. The containers are manually moved into position along set tracks for improved safety at high sea states. CDS has put in place a strong strategy for the implementation of the project, from its current Feed 2 stage to its fully delivered, handed over and functioning state, taking into account all project stakeholders. The transition plan and construction program steps are as follows. During the detailed design phase, CDS will carry out a last iterative check of each element of the ship, such as structure, propulsion and handling systems, and warship architecture. This stage will also include the final design reviews with all parties, which will lead to the plan appraisal phase, where the full design documentation is submitted to the classification authority, Lloyd's Register. Detailed specification and detailed construction planning and scheduling. CDS will support the respective parties by advising on construction processes and procurement options available for the construction phases, as well as providing the necessary project management and planning expertise ahead of the construction phase. Throughout the construction phase, CDS will offer its project management, quality assurance and surveying services to support the project stakeholders during the procurement, quality control, surveying and test of individual and integrated systems. The launching and handover phases will see CDS provide its engineering analysis and risk management expertise for a safe vessel launch, as well as the necessary testing services required during a final handover, for example, testing stability and sea trials, after which will follow the issue of the project documentation, including classification and certification documents shown here. The detailed design elements produced by CDS during this feed, i.e. the propulsion and handling systems, have been designed in accordance with the NATO Naval Ship Code and Lloyd's Register rules and regulations. With respect to the propulsion systems, the designs have incorporated the measures specified in these codes, including, for example, the minimum manoeuvring and redundancy requirements, the recommended fire safety practices, as well as transmission and emergency steering systems. Similarly, the handling systems were designed to exceed these codes' structural, electrotechnical and operational requirements. It is crucial to ensure the successful implementation of the design standards during the construction and commissioning of the vessel. For this, CDS will put in place the necessary site surveying, dimensional and quality control, as well as testing support for each key construction phase. For example, CDS will support the testing of individual systems, such as machinery, prior and after its integration within the ship construction modules. The successful implementation of the project will be guaranteed by a clearly defined organisational structure, incorporating all project stakeholders as drawn here. It can be seen that CDS will play a major supporting role within core activities including naval architecture, project management, surveying, testing and certification. Ship construction projects, CDS and the contracting shipyard will be committed to a handover delivery date. The overall timescales of the project are shown on this Gantt chart. First, the detailed design phase will take place between April 2014 and July 2015. The construction and detailed specification between September 2014 and April 2015. The detailed construction planning and scheduling between March and July 2015, leading to the construction phase, which will take place between July 2015 and July 2017. And finally, the launching and handover phases concluding the project will take place during mid-July 2017. A comprehensive risk assessment was carried out during the initial phases of the project. This has been extended to include the business risks as set out in the comprehensive FMECA. Besides the risks examined in the FMECA, financial risks form a key focus for the business case. The target cost for one Black Swan is £65 million, equating to approximately 1/4 of the cost of a Type 26 frigate. The costings for the project are based upon empirical values from a range of similar vessels. The National Environmental Research Council kindly supplied detailed costings for the building of their latest research vessel, the RRS Discovery. The vessel is similar in size and specification to the Black Swan and provides a valuable insight to the pricings which are not publicly accessible. The chart shows how the major costs are apportioned. These graphs are based on industry-standard pricing systems. A detailed SWOT analysis has identified that the primary strength in the business was its flexibility and adaptability. A principal weakness was felt to be the lack of chartered status, placing an emphasis upon the need for at least one of the team to obtain chartership as quickly as possible. An opportunity has been identified to exploit the need for versatile multi-mission surface vessels and to ally this with addressing the need to offer value for money in the current climate. The principal threat was felt to be the heavy reliance placed upon being awarded the Feed 3 phase of the project, possibly in competition with other bids. To conclude, an innovative Feed 2 design has been produced to meet the current and future needs of the MOD. The key selling points of the vessel are a capability to launch and recover a range of manned and unmanned platforms, large mission bay to accommodate and utilize capability packages in the form of ISO containers, a relatively low budget at £65 million. Cygnus Defence Solutions are an exciting new company striving to bring innovation, quality and flexibility to the next generation of defence projects. This starts with the Black Swan. Innovating today for security tomorrow. The hour is later than you think.